when we are simplifying rational expressions, our main tool, our main technique is to cancel factors common to the numerator and denominator of that fraction. Now, one thing to keep in mind, especially in this section and in the next section, is that when you are simplifying a rational expression, in order to cancel something out, if you want to cancel a pair of something, let's just call it thing for short, in order to do that, there are some requirements. Thing must be a factor, must be a factor of both the numerator and the denominator of the same fraction. So that means that if thing appears in two different fractions, then it can't be canceled. If thing is not a factor, then it can't be canceled. If thing is a factor of the numerator but not the denominator, then it can't be canceled. So it's really, really restrictive, and we've gotten quite lucky when we encounter something that can be canceled out. Now there's only one exception to this rule, and that arises when we are multiplying two fractions together. When we are multiplying, specifically multiplying two fractions, we can do something called cross-canceling. And this refers to canceling something out let's just call it thing in brackets for short, even if this thing appears in two different fractions. Of the numerator and denominator of two different fractions. So let's look at a couple of different examples of simplifying rational expressions, and let's do some drills to see when we can and cannot cancel something out or cross-cancel something out. So for example, we have the problem x plus 6 over x plus 3 times x plus 9 over x plus 3. Can we cancel or cross-cancel the copies of x plus 3? The ones here in the two denominators. And the answer is no. And the reason is that x plus 3 appears in the denominator of both fractions. If we want to cross-cancel something, then it is required that one of the quantities be in the numerator level and one of the quantities is in the denominator level. So they have to counterbalance each other. But here, both of the quantities x plus 3 are in the denominator. And so there's no counterbalancing happened. All the weight is on the bottom, and these cannot be canceled out. Just to get a little practice, do you think we can cancel any x's? For example, do you suppose that we can cancel out maybe these two x's on the left? Or do you suppose we can cross-cancel an x on the left with an x on the right? The answer here is still no. And the problem is that x is not a factor in any of these fractions. And that's because all of these x's, every single one of these 4 x's, is in contact with a plus sign. So as we discussed yesterday, if your x is in contact with a plus sign, it cannot be canceled out because it's not a factor. Okay, let's try it with this example. So in this case, we have x plus 6 over x plus 3 times x plus 3 over x plus 9. So the question is, can we, in this case, can we cancel the copies of x plus 3? The answer in this case is actually yes. Finally, right? Finally, yes. We can cross-cancel the x plus 3's. Because this is a multiplication problem, we have the special privilege of being able to cancel out a common factor of 2 different fractions. The x plus 3 in the denominator of fraction number 1 can be cancelled with the x plus 3 in the numerator of fraction number 2. So multiplication problem allows us to cross-cancel. What about in this example? We have x plus 6 over x plus 3 divided by x plus 3 over x plus 9. And once again, let's ask, can the x plus 3's be cancelled or cross-cancelled? The answer here is no. Let's make that red. The answer here is no. And the difference between this problem and the one that we did just earlier is that this time, this is not a multiplication problem. We can only cross-cancel when we are multiplying, not when we are adding, subtracting, or dividing. Multiplication is very special here. Okay, so final drill, can we cancel the x plus 3's in the following problem? X plus 3 over x plus 3 divided by x plus 6 over x plus 9. In this case, the answer is actually yes. Even though this is a division problem, that's okay, because we're not trying to cross-cancel the x plus 3's. Both x plus 3's are within the same fraction. We are not cross-canceling because both x plus 3's are in the same fraction.